Hi friends, welcome to this chemistry quiz on chemical reactions and equations. We are going to be discussing some really important questions and I'm going to show you the tips and techniques on how to solve questions on chemical reactions and equations. So friends, be sure to watch the entire video. So guys, are you ready and excited for this quiz? So let's go ahead and start. So I see a lot of folks are out here. Welcome everybody. Great to see all of you here. And if you haven't checked out our website, do check it out, manochaacademy.com. We've got these courses for you on physics and chemistry, and we'll be launching more courses on chemistry and math soon. So do check it out. The links are given below, and we have great discounts going on right now. And in these courses, you'll get interactive videos. We are having live classes there also starting from next week, quizzes and questions, and you'll get replies from me. So guys, do check it out. And if you haven't hit the subscribe button for our YouTube channel, Manocha Academy, hit it right now and click on the notification bell so that you don't miss out on these live classes. We're having live classes on physics, chemistry, and maths daily at 8 p.m. So guys, do be sure to attend the classes and do share it out with your friends and family so that we can have more people out here. Okay, great. Guys, are you ready for the quiz? Let's go ahead and start. Here's our first question. Chemical equations are balanced to satisfy which law? So what do you guys think? Hello, I see a lot of folks are here. Good evening, good evening. Sorry if I can't take everybody's name. So I see Manu, Diptanshu Panda. Hi, Ayush Kundar. Hello, good evening everyone. And go ahead and try this first question of our quiz, chemical reactions and equations. Here's the first question for you. So chemical equations are balanced to satisfy which law? What do you guys think? Is it the conservation of momentum, conservation of energy, conservation of mass, or conservation of weight? And great to see a lot of you interacting here and trying out the answers. Excellent. So I see most of you got the right answer, which is C, right? It's based on conservation of mass. Okay. And why is that? Because when we balance a chemical equation, we want the mass of the reactants to be equal to the mass of the products, right? So we want the mass to be balanced. Okay. So for example, if you take a simple equation, let's take H2 plus O2 gives H2O, right? And when we balance this equation, we want the mass of the reactants, which is these guys on the left hand side. So the mass of these should equal to the mass of the products, right? And we can also informally say it's conservation of weight, right? Because mass and weight are connected, you know, in physics. But normally it's best to write that it's based on the law of conservation of mass, right? Because we are truly balancing mass, not the weight here. So excellent. You guys are amazing. Most of you got the answer correct. Great. So are you ready for the next question, guys? Here it is. A metal burns in air with a white dazzling flame and produces a white powder. What do you think is the product? Is it A, magnesium, B, magnesium oxide, C, sodium, or D, sodium oxide? What do you guys think? So guys, go ahead and try this out. Okay, great to see answers out here. So very good. So look at always in chemistry, when you read the question, look at the clues. So what are the clues that we have here? It says a metal burns in air, right? And it produces a white dazzling flame. And then finally it produces a white powder. And we need to find what is the product. So guys, look at the clue in chemistry, and always the questions are very colorful, right? With all these colors and conditions mentioned, and always think of what's the reaction here. So before you jump to the answer, try to connect the question to the reaction. Okay. And so good to see a lot of answers here. So what do you think the reaction is going to be here? Okay. Some metal burns in air, right? So there's some metal which is burning in air, which we can say oxygen, and it produces a product which is a white powder. Okay. And it says it burns with a dazzling white flame. So guys, you know what is the metal? That's right. It's magnesium, which is also used in the firecrackers, because in firecrackers, you know, you want a white dazzling flame. So magnesium plus oxygen. And guys, can you guess what is going to be the product? Excellent. I see a lot of answers here. And those are the right answers I'm seeing. It's going to be magnesium oxide, and it's a combination reaction, but the valency of magnesium and oxygen is 2, so it's going to be MgO, not MgO2. Okay, and now the last thing to do is we should balance our equation, right? So the question is, what is the product? And the product, guys, you know, is on the right hand side of the equation. Okay, so excellent. The correct answer is magnesium oxide, and 2 is not important, right? Because we are looking at MgO, the product. So it's not magnesium, and sodium burns with a, you know, golden yellow flame. Okay, here it says white dazzling flame. So guys, if you want to know, sodium burns with a, it burns with a golden yellow flame to produce sodium oxide, right? So the best answer is magnesium. The correct answer here is magnesium oxide. Great. Let's move on to our next question then. What is the type of reaction for the one given below? So we have sodium sulfate, can you see, is reacting with barium chloride to produce barium sulfate and sodium chloride. So is this a combination reaction? Is it a decomposition reaction, a precipitation, or a neutralization? So guys, what do you think is the answer? And great to see all of you participating in the quiz. So I want all of you to think and try. Excellent, guys, please try the question. So what do you think is the answer here? Okay, so I see a lot of folks are saying C, some are saying B, D. So what do you think the answer is going to be here? So let's go and look at our options here. So can it be a combination reaction, the first option? So it can't be a combination, because in a combination, you know that 2 or more things combine to form one product, right? So combination reaction always gives one product. But here you can see there are 2 products here, right? Can you see the 2 products here? Barium sulfate and sodium chloride. So this guy is out, right? Next, decomposition. Decomposition is the opposite of combination. There should be one reactant. So only one reactant. But here you can see there are 2 reactants, sodium sulfate and barium chloride. So option B, guys, is out. Okay. Now precipitation. What does precipitation mean? So precipitation reaction is based on there should be a precipitate that's formed. And what is a precipitate, guys? Do you guys know? So precipitate is something which is insoluble in the solution, or usually the solvent is water. So we can say something which is insoluble in water. Okay. So we know that, and this reaction, if it's happening in water, we know that sodium chloride is soluble. So we write AQ for that, right? Because you know salt dissolves in water, but barium sulfate, it does not dissolve in water. So it is, this guy is insoluble. And in some books it's shown with the, so let me write this plus here again. And in some books it's shown as barium sulfate with a downward arrow to show precipitate. Like upward arrow is used for gas, downward arrow, or you can write barium sulfate and with the symbol solid. So because this guy is not soluble in water, it settles down as a precipitate. So guys, this is a precipitation reaction. And it can't be neutralization, because guys, you know what is neutralization? Neutralization is acid plus base gives salt and water, right? And here we don't have an acid and base reaction here, as you can see. So this option is out, right? So always analyze the options here and try it out, right? Very good. Somebody is asking, what is the color of barium sulfate? I think it's a white precipitate, right? So yes, this brings about a very important point. Guys, do learn your colors. It's very important, because the chemistry exam is a colorful exam. It's full of colors and observations. So whenever you see some important color, do learn it up. And you can check it if I'm wrong. But as far as I remember, it's a white precipitate which is insoluble. Okay, excellent, guys. Let's go to the next question. Rusting of iron. So as you can see in this picture, this railing is made of iron and it's getting rusted here, right? Can you see that reddish brown rust? So is it an example of rancidity, corrosion, reduction, or decomposition? Guys, what do you think here? Come on, this is, I think, a simple question. So I want all of you to get this right, guys. What is it? So rancidity, right? Let's go over our options. You know that when food spoils, we call it rancidity, right? So food which is left out in the open, it turns bad due to slow oxidation in the air, right? And we shouldn't be eating the rancid food. It has a bad taste. So this one is, we don't have food here, right? It's iron. So this is out, okay? And can it be reduction? No, because you know in rusting, what is the reaction? Iron is reacting with oxygen and water, right? In the presence of oxygen and water. So this guy's out. It's not a reduction reaction, right? What about decomposition? So you know that in decomposition, you should have only one product, right? So here you can explore the formula of rust. I'll just write it for now like this. So clearly it's not decomposition because there are three reactants here. So this guy's out, correct? So very good, guys. The right answer is it's corrosion. What does corrosion mean? The surface gets eaten up, right? Because you know that when iron reacts with the oxygen in the air and with the water vapor or water, right, it forms iron oxide, right? So it forms iron oxide, which is rust, and the layer gets corroded away. Okay, guys? And so that's why it is corrosion of the metal. So the metal gets corroded here, and rusting is a good example. And for other metals, we can also say they corrode, but here the example is rusting of iron. Excellent, guys. So let's go on to our next question here, which is in the electrolysis of water equation, what should be the physical state of water? So solid, liquid, gas, or aqueous? What do you guys think? Right? So in the electrolysis of water equation, so first think about the equation. So here we are talking about electrolysis of water. And what should be the physical state of water? What do you guys think here? Okay, good. I'm seeing a lot of answers here. So what should be the physical state of water? So before we think about the physical state, let's first write down the equation. Okay. So what is the electrolysis? You know that water, right? And we pass electric current through it. So when we pass electric current through water, you know that it breaks down into hydrogen and oxygen. Okay. And guys, don't forget to balance your equations. So let me quickly balance that, right? And now we've been asked, what is the physical state? So physical state, you know, these are the important states in your syllabus: solid, liquid, gas, or aqueous, right? So what should we write for here? So I see some of you are saying B, some of you are saying D, gas, okay? Let's decide. So we know that hydrogen and oxygen, which is produced, is definitely a gas. So let's mark that here. So the products is a gas, but it's asking what should be the physical state of water, okay? So water, you know, is when electric current is passed through water, water is not in a gaseous state because we're not heating it, right? Just we are passing electric current. So this option is out, okay? And solid is definitely out, right? So I'm seeing some of you are thinking of B and D. So this is a little tricky, confusing question, right? What do you guys think it's going to be? Okay, so let's understand what's the difference between liquid and aqueous, right? Liquid means something which is in liquid state, right? Like water, you know, exists in liquid state. You can have molten sodium chloride. So if salt is heated a lot, you can get it into a mushy liquid, right? So something in a liquid state is marked with an L in the normal state of liquid. And aqueous usually means, aqueous means that something which is dissolved in water, right? So if you take something like salt and dissolve it in water, so let's write down an example of aqueous state. So if sodium chloride is dissolved in water, we'll say it is in aqueous state, right? We write NaClAq, right? Or any other soluble thing, right? Let's say you have an alkali potassium hydroxide, right? So when that's dissolved in water, we write aqueous. So when something is dissolved in water, we write aqueous, but water alone is written as a liquid because you can't say water is aqueous. It's making the thing which dissolves in water is written as aqueous state. So very good, the guys who got it right. Answer is B for this interesting question, because water is in its liquid form, right? We don't say water is in an aqueous form, right? Because aqueous means something dissolved in water. Okay, excellent guys. So take a note of this important point, and you must not confuse your physical states. They are very logical, and this is a definitely liquid is the answer here. Very good guys. So good going. Let's go to the next thing, and here I don't have any options because I want you to go ahead and balance this chemical equation. So I've given an equation for you. C5H10 plus O2 gives carbon dioxide plus water, right? And for those of you interested, that C5H10 guy, you guys will be learning it in your organic chemistry chapter. That is pentene, because it has 5 carbon atoms, right? So that's the compound. It's a hydrocarbon, and when you burn it in oxygen, you get carbon dioxide and water vapor. Okay, so guys, get your pen and paper ready and go ahead and try to balance this equation. So guys, please go ahead and try it out. Okay, so I'm seeing some of you guys are trying, and so I want all of you to go ahead and try to balance this equation, and let's see if we can do it really quickly, right? Is there some quick shortcut techniques here? So C5H10 plus O2. So who's going to give me the answer? Is carbon dioxide plus water, right? And remember, in a balancing equation class I taught, and if you haven't watched the class guys, go ahead and check it out, right? So good, I'm seeing some answers here, so I want you two guys to try. I taught you the different methods. One is the hit and trial method, the table method, and there's another ABCD method for complicated equations. And my recommendation is that first try hit and trial, okay? If you can do it quickly with hit and trial, nothing like it, because it's very fast. And then if it doesn't work at all, then you should go for the ABCD, which is that coefficients method. So guys, if you don't know how to balance equations, go ahead and check out my video. You can search for balancing chemical equations, Manocha Academy. Okay, so guys, go ahead and try this equation. Very good, I'm seeing some answers out here. Okay, but I don't think I've seen the right answer till now, but let's go ahead and try. Because I also don't fully remember the answer, so let's solve this ourselves. Let's go ahead and try it out here. So I'm going to try with the hit and trial first, right? That's the fastest. So what do we do here? Hit and trial means try to balance the elements which are easiest to balance. Start with the easy ones, right? Because you know oxygen is all over the place, so we'll not start with oxygen. Let's first try carbon. So there's 5 carbon here, and I'm going to put 5 here. Right, so carbon is balanced on the left and right hand side, right guys? Okay, now you can see hydrogen is 10 on the left hand side. So guys, follow me. So can you see hydrogen is 10 on the left and it's only 2 on the right? Okay, so let's go ahead and multiply this also by 5 so that it will be balanced. Okay, so guys, can you see that? Right? Okay, I think I see one. No, I think the answer is almost correct, but there's some mistake there. But let's go ahead and take a look. So guys, keep trying this. Can you see what we've done here? So guys, can you see that carbon is balanced? 5 here, 5 carbon, 10 hydrogen, and 5 times 2, right? So don't forget, you have to multiply 5 into 2, so that's 10. So both carbon and hydrogen are taken care of. Now let's look at our oxygen guy. Okay, so on the left hand side and right hand side, how many oxygen do we have? So can you see oxygen is 2 on the left hand side. So let's write that 2. And on the right hand side, how many oxygen are there? 5 times 2, because 5 carbon dioxide. So 5 times 2 is 10 plus 5 times 1. Okay, so that's going to be 15. Guys, do you follow me? Okay, so very good. Guys, go ahead and try. I think Sanathagari Alekia, he has the right answer. Very good. I see some of you with the correct answer. Mukund Kumar Singh, right? I'm seeing some right answers here. Very good, guys. So good going. Take a look at this. So you're following me, and let me write down carbon and hydrogen. So that was balanced, right? So carbon, we have 5 here, and we have 5 here, and hydrogen, we have 10 here, and 10 here, right? So I'm writing these down just to explain you. So these guys are balanced after putting those 5s, but this guy, oxygen, is causing the problem, right? And let me show you a very simple trick how to solve the oxygen part quickly. So what you can do here is, since we have 15 on the right hand side more, right? And we have only 2 on the left hand side. So let's use our fraction technique, which I taught you in the video earlier, right? Remember? So if we do 15 by 2, you know that 2 is going to cancel, right? And so we are going to get 15 here. So 15 on the left and 15 on the right. Guys, do you guys agree? Okay. And now can you see our equation is balanced? Only problem is we are left with the fractions. Okay. So look, we've not even gone to the ABCD method. We are just trying with hit and trial, and we've balanced our equation except for the fraction. And now it's very easy to remove the fraction, because the denominator you can see is 2. So we need to multiply this whole equation by 2, right? So you just need to multiply the whole thing by 2. So let's go ahead and do that. So this is going to be 2. This 2 will cancel out, and this 5 times 2 is going to become 10. And again, 5 times 2 is 10. So guys, can you see? I saw a lot of you got this right answer. Excellent. Great going. So this is a quick technique to get to the answer quickly. And what is our final answer here? So this is going to be 2, and we'll have a 15 oxygen here, and that's 10 and 10. And now guys, you can check the equation is balanced. Let me write water one more, or I'll just erase that and write 10 here. Okay. So this is going to be 10 water, right? Excellent. So can you see guys, the equation is now correctly balanced. Okay. So remember, go for hit and trial. And if you have just one element like this left, you can finish it off with the fractions and you will get your correct answer. Okay. But if it doesn't work out, you can go for, there's another technique, or if you find some of these difficult, you can go for the ABCD method. And to check it out, I've explained it clearly to you in the balancing chemical equations video. Great guys. Now let's move on to our next question. A white crystalline solid X on heating produces a yellow solid and reddish brown fumes. What is X? So again, you need to be a detective here, right? I told you in chemistry, it's going to be full of clues. So can you see white crystalline solid X, right? On heating, it's producing a yellow solid and reddish brown fumes. So what do you think this X guy is? So is it sodium nitrate, copper nitrate, ammonium nitrate, or lead nitrate? What do you guys think? Come on. Go ahead and try this out. Okay, some of you are saying copper nitrate, some think sodium nitrate. I see some are saying lead nitrate. So guys, what do you think is the answer here? Okay, let's try this out. So for our first option, when you heat sodium nitrate, on heating this actually produces sodium nitrite plus oxygen. I won't balance the equation because our goal is to see the observation here, right? And oxygen, you know, is a colorless gas, right? So there's no reddish brown fumes here. So this can't be our option. Let's try the next one. Copper nitrate, usually copper is bluish or greenish in color. So this guy, as far as I remember, copper nitrate is a blue colored salt. So this guy's out because our question says white crystalline solid X, right? So just, we don't have to think about the equation. And sodium nitrate, I think, is white in color. So we tried it out, right? Again, guys, you need to remember the colors. So whenever you see colors in chemistry, underline it in your book, right? Mark it down and learn it up. Okay. Ammonium nitrate. Now, what does this guy give, right? So when you heat ammonium nitrate, you're going to get N2O, this gas, right? Plus water vapor, right? So this doesn't produce any yellow solid. So ammonium nitrate is also out. Now let's take a look at our last fellow, which is lead nitrate. So PbNO3 whole 2, right? Because valency of lead is 2 here. And so that's going to give lead oxide plus NO2 plus oxygen. Okay. And this guy, lead nitrate, is white crystalline. So you need to learn up your colors. It's a white crystalline solid. Lead oxide is yellow in color. Okay, PbO, that's yellow in color. And this guy, NO2, nitrogen dioxide, has reddish brown, it's gas, right? So this is a reddish brown gas, and oxygen, guys, you know, is colorless, right? So this guy NO2 is reddish brown in color, and oxygen, you know, is colorless. So if you look, D is our correct answer. So you need to be like Sherlock Holmes in the chemistry exam, right? Analyze the options, don't jump to the answer. Okay, that's my advice to you, that take a look at the clues and go ahead and analyze the question, analyze the equation, then you'll never get your answer wrong. Okay, superb, guys, excellent. So this is the correct answer, and many of you got it right. Very good. I think you'll find this reaction in your books. It's a very important reaction. So guys, are you ready for our next question? Here it goes. What are the products in the reaction below? Copper plus zinc sulfate. And can you see that aqueous means it's in water, right? So is it going to give copper sulfate plus zinc, copper oxide plus zinc sulfide, copper sulfide plus zinc oxide, or none of these? So guys, what do you think is the answer here for this question? So again, I want all of you to try it out and try these important and interesting questions. They'll really help you to revise the chapter and clear your concepts. And guys, if you haven't hit the like button, hit it right now, and also hit the subscribe button for our channel and the notification bell so that you don't miss out on any live class and any of the videos that we upload. And guys, do please share it out with your friends so that we can have more people on our Manocha Academy family. Okay, very good. I see a lot of you are trying. Some are saying A, D. Okay, so there's, I think, maximum answers are either A or D. Displacement reaction, D. What do you guys think? Okay, so again, be a detective, right? Think and analyze the question here. Let's look at our reaction. What does it say? Copper plus zinc sulfate. Okay, so if we go for our first option, basically the first option is saying copper sulfate plus zinc, right? So what type of reaction would this be? So if this reaction happened, what reaction would it be? Displacement, right? Because guys, can you see that copper is displacing or kicking out zinc from zinc sulfate, right? So it's like substituting or displacing the zinc. So it says, okay, zinc, you go away. I'm going to join with sulfate and become copper sulfate, and then zinc is going to be left alone, right? So this, if this reaction happens, it's a displacement reaction, as you can see, right? But guys, this is where the trick is. Can copper displace zinc? What do you guys think? Can copper displace zinc? Yes or no? So what do we need to think about that when we are thinking that about displacement? We need to think about the reactivity series of metals, right? So the reactivity series. And that you guys would be reading in your metals and non-metals chapter, right? So reactivity series is very important. And guys, as you know, in the reactivity series, which starts with, I think, potassium, sodium, right? So potassium, sodium, calcium, and so on. And then zinc is somewhere here, and copper is way down below, right? So zinc is above copper in the reactivity series, right? So zinc is above copper. That means copper is less reactive than zinc, because as you go down, the reactivity of the thing decreases. So reactivity decreases as we go down. Right, guys? So excellent. I see a lot of you caught that one. So therefore, copper cannot displace zinc because copper is less reactive. It's lower in the reactivity series than zinc. So very good, guys. So this will not be the products. It's going to be no reaction. Nothing will happen. If it was the opposite, zinc plus copper sulfate, then a reaction would happen, right? Then you'll get zinc sulfate plus copper. So the right answer here, superb, guys, is going to be D. None of these. So this was a trick question, and the answer is no reaction. Okay. So please make a note of this question. Nothing will happen because copper cannot displace. It's less powerful than zinc. Great, guys. Now let's go to our next interesting question. What substance is being reduced in the reaction below? What do you guys think? The reaction is zinc oxide plus carbon gives zinc plus carbon monoxide, right? And so which substance or what substance is being reduced in the reaction below? So go ahead and try this out. So So guys, you know what type of reaction is this one? So what is this type of reaction known as? Okay, so before you try the options, can you tell me what type of reaction is this, the one here? So who can tell me? Displacement? No, it's not displacement. Good, I see some of you are saying redox, right? So I see Kanishka, right? Kriti Gupta, right? So good. So a lot of you got that. This is a redox reaction. Excellent, guys, right? Very good. So in a redox reaction, let me show you a very simple trick how to analyze it. So let's write down this reaction first. Zinc oxide plus carbon. And always write your reaction so that while writing you're thinking them, right? So in the test when you're doing the reactions, you must write them down. And so this is a redox because one substance is going to get reduced and another is oxidized. And let's see why. Can you see that zinc oxide is losing oxygen and becoming zinc? Okay, so guys, can you see that? And what is happening to carbon? Carbon is gaining oxygen and becoming carbon monoxide, not CO2, it's carbon monoxide here. Okay, and guys, so when carbon gains oxygen, what can we say? Carbon is being oxidized, right? Because oxygen is being added to it. So we can say carbon is oxidized to carbon monoxide, right? And zinc oxide is being reduced to zinc here. So guys, please write down the reactions and do it this way I've shown you. Draw the arrows, right? And write down reduction, oxidation, or reduced and oxidized so that it's crystal clear to you. Okay, so there'll be no confusion. So please take a look how I've analyzed this reaction, and please don't be lazy about it. Write down these arrows so that you don't make any careless errors here. Okay guys, right? And so now who's being reduced, oxidized? Whenever they ask this question, who's the guy who's reduced or oxidized? Please remember one important tip here. It's always the reactants, right? So the answer is never the products. It's always one of the reactants. Okay, because what substance is being reduced or oxidized, it's always the guy on the left hand side. Many times people write the answer as zinc or carbon monoxide. So these options are wrong because these guys are the products. Okay, so it can only be either A or B, right? Only the reactants. And now you can pretty easily see, can you see that zinc oxide is being reduced because why? It's losing oxygen. So it loses oxygen, right? So you know that addition of hydrogen or losing oxygen means reduction, right? Similarly, gain of oxygen or losing hydrogen is oxidation. Clear? So guys, who's being reduced here? Excellent. I see many of you got the right answer. Superb. It's going to be zinc oxide. So zinc oxide is reduced to zinc because it loses oxygen. Okay guys, is this super clear? Please take a look at this equation the way we've shown it with the arrows and all so that you have no confusion. And don't forget, the answers always the reactants in these questions, right? The guys on the left hand side. Only if they ask you what is it reduced to, right? Then it's zinc. But who is being reduced is always on the left hand side. Very good, guys. I see some of you are mentioning, so we can discuss that also. There's a reducing agent, oxidizing agent. So some people are asking, I see Panda, PUBG Mobile is asking, right? So let's talk about that also. So guys, if we see here, so let me just erase this part, right? So I'll get rid of that guy. So can you see that this guy is reduced, right? So zinc oxide was getting reduced here and carbon is getting oxidized, right? Oxidized. And now if we ask that who is the reducing agent and oxidizing agent, okay? So here the answer is opposite, okay? Because carbon is getting oxidized. So if you take an example of a travel agent, right? Travel agent helps you travel, right? Of course, he may go on vacation also and travel, but the goal of the travel agent is to help you travel. Similarly, what is the goal of the reducing agent? So if we talk about this word, so what is the goal of the reducing agent? So reducing agent helps the other guy, so helps other person or the other substance, so helps the other to get reduced. Okay, so guys, who do you think is the reducing agent in this question? So zinc oxide is being reduced, but who's the reducing agent? Can you guys tell me? Very good. Carbon is the reducing agent, right? Because carbon is helping zinc oxide get reduced. So guys, you got it right. So can you see this guy is the reducing agent? Okay. And similarly, zinc oxide is helping carbon to get oxidized. So zinc oxide will become the oxidizing agent. So these are the main terms in this redox reaction. Who's reduced, who's oxidized, or who is the reducing agent, who is the oxidizing agent. Okay, and one important trick is it's the opposite. Since zinc oxide gets reduced, he becomes the oxidizing agent, and carbon gets oxidized, so he becomes the reducing agent. I know this all sounds a little confusing the first time, but if you draw these arrows and just understand this concept, it's going to be super easy. Okay, so one last time for you guys, right? Just to clear it up, if you look at the equation, are you clear about who's reduced and oxidized? Zinc oxide is losing oxygen. So if you look here, zinc oxide loses oxygen, right? So he is reduced because loss of oxidation is oxygen is reduction. So he is reduced, right? Can you see that? But he's helping the other guy to get oxidized. So he is the oxidizing agent. He's supplying oxygen, right? And carbon is getting oxidized to carbon monoxide. Oxygen is being added to carbon. So carbon is definitely being oxidized. But he is the reducing agent. Just like a travel agent, he helps the other guy get reduced. So he is the reducing agent. So please remember, can you see the opposite thing? The guy who's reduced is the oxidizing agent. The guy who's oxidized is the reducing agent. Very good. Okay. So it doesn't matter if you got a bit confused, go back and replay this part again. And I'm sure you'll find it easy. And if you still have doubts, put it in the comments below and I'll try to respond to your comments as soon as possible. Now let's take a look at our next question. Write the chemical equation for the reaction of sodium and water and also write the physical states, the solid, liquid, gas, aqueous, remember? So go ahead and try this, and I've not given any options here. This is a simple question. I want all of you to try this. Okay, so go ahead and try the chemical equation for this reaction. So let me at least start it out for you. So what is it going to be, guys? The reaction is going to be something like we have sodium, right, plus water, right? And what do you think we are going to get here? So what will be the products? And you need to finish off the physical states. So I want all of you to try this. It's been an amazing session because I'm seeing so many answers in your chat and you guys are really focused on the questions. So it's great to see that, right? That's the whole purpose of these live sessions where you guys are really analyzing and looking at the questions, right? And not just, listening to me. So we are all participating in this together. So that makes it more fun. Okay guys, very good. And guys, do hit the like button if you like this, and please share it out with your friends so that we can have all of your friends also on these live sessions. Okay, so good, I'm seeing some answers. I see some of you are saying sodium oxide plus hydrogen. Some are saying sodium hydroxide plus hydrogen. That's why I gave this interesting question, because what does it, what's happening here? Okay, so let me show you a trick of how to analyze this reaction. So water we can break down into H and OH, right? Water is having the H plus, right? And OH minus. So if you think that's the hydrogen ion and the hydroxyl ion, right? So if you break down water like this, right? So if I split water, so one way to split this is H2 and O, but we are going to split it as H and OH, okay, for this reaction. And sodium is going to displace this hydrogen guy, because remember we talked about reactivity series, and sodium is way higher than hydrogen in the reactivity series, right? So sodium is definitely more reactive than hydrogen. So it's going to displace the hydrogen in here. So what are we going to get? So sodium is going to combine with Na and OH, and it's going to displace out this H guy. Right? So please take a look at how we are analyzing this. So you won't have to memorize this equation. Water you can break down into H plus and OH minus, and then we've got sodium displacing the hydrogen from it, right? So you get NaOH plus H, okay? But can you take a look, is my answer correct, or is there any issue here with my answer, right? Remember, what is the atomicity of hydrogen, guys? So should I write H or? Very good, you guys are saying H2 because it's a molecule, right? Finally, the equation is written not in terms of atoms, in terms of molecules. And you know H and H will combine to give the hydrogen molecule because hydrogen is diatomic. One molecule contains two atoms. Clear? Okay, so this is our reaction and it is a displacement reaction where sodium has displaced out hydrogen. So please remember, this is a very simple displacement reaction where the metal is because sodium is so reactive, it kicks out hydrogen from H2O, but it doesn't kick the OH, the H from the OH, only this H plus, and it gives you NaOH plus hydrogen, right? And you can remember because sodium is Na plus, right? A sodium ion. So we've got this here. Now we need to write down the physical states, right? Before we write down the physical states, guys, don't forget to balance the equation, right? So we need to balance it. So guys, can you balance this equation for me? Okay, and while you're balancing, let's discuss the physical states, right? So what is the physical state of sodium? Sodium, you know, is a metal. It's a solid, right? A soft solid, but still a solid. So we're going to write S here. Water, what should I write? Remember, we discussed in this class, for pure water, we don't say aqueous because water can't dissolve in water. So this is going to be a liquid here, right? And what about hydrogen is clearly a gas here. So let's fill in, I'm using green color, G for green, G for gas, right? So that's gas. What do I do for NaOH here? What do you guys think? So sodium hydroxide, what state should I put for NaOH? Some of you are saying liquid, and guys, it's not sodium oxide here, right? Because I've shown you that sodium only displaces this H plus or the H part of water. It doesn't displace both the hydrogens. Then you would have got sodium oxide. So note this reaction, sodium oxide is not the right answer here. Okay. So what is NaOH going to be? Sodium hydroxide, you know, is an alkali. It's soluble in water, right? So sodium hydroxide, and you're going to learn that in the acid-base chapter. So it's soluble in water. So its state is going to be aqueous. So let me write AQ over there, right? So this is aqueous. It's not solid and definitely liquid. It's not a liquid here. It's dissolved in water. Okay, because you know sodium hydroxide is an alkali, a base which is soluble in water. So great, we guys have got that, and let's quickly balance out this equation, guys. So that's the last thing that's left for us, is to balance this equation. So what is the balancing here? You can see sodium is already balanced. So we are going by hit and trial. Sodium is balanced. H2, hydrogen I think is not balanced. It's 2 here and 2 plus 1, 3 here. Oxygen is balanced. So the only guy giving us trouble is, I think, hydrogen, right? So what is a quick way to balance this equation? Again, we need, we have 2 here, we have 3. So I can quickly again use our fraction trick here. So can you see my equation is balanced now? Because half times 2 is 1. So that's 1 plus 1, 2, and we want 2, right? But we can't leave out fractions. So we're going to just multiply this whole equation by 2 quickly. So 2, 2, 2, and this guy goes, right? You can also balance it with the normal method, but the fraction sometimes is really fast, and we've got the right answer. Okay, very good. I see Jay Reddy also has the right answer. Excellent here, guys. Very good. So guys, but be careful. Some of you are still writing sodium oxide. It's not sodium oxide. Some metals give their oxide, but sodium, potassium, these very reactive guys, they give their alkali or the hydroxide. So be very careful of this. That's why this is a little tricky reaction, because sodium oxide is not the right answer in the product. It's sodium hydroxide. Very good. Okay, guys. So hope you found that question very useful for you. And here's another question. What is the reducing agent? So we talked about that today, right? Oxidation, reduction, who's oxidized, who's reduced. What is the oxidizing agent? What is the reducing agent? So guys, what do you think is the reducing agent in the reaction below? So what is our reaction? Copper oxide plus hydrogen gives us copper plus water. Okay. And guys, remember, before you jump to the answer, always analyze it with those arrows. Who's being oxidized? Who is being reduced? Okay. So please remember the arrows that we did today. So let me go back to that slide here. So can you see we talked about who's being oxidized and reduced? So guys, please try it like this and decide carefully who's the reducing agent in this. Okay, very good. I see answers here, but I won't tell you the answer because I want everybody to try. Okay, I don't want to give out the answer in this session, and do write your answer in the comments below, and I promise to reply to them as soon as possible, guys. I do look at your answers that you write after these live sessions, and some of you are really fast, you know. Before I've closed my live session, I see the answer in a minute. So it's amazing to see that, guys. Come on, I want all of you to go ahead and try this important question, and these will really help you solidify your concepts, and you'll really revise by practicing more questions. Okay, so guys, do write your answer. I look forward to reading your answers, and as I mentioned, do check out our website manochaacademy.com. We've got some great courses for you at really big discounts going on right now, so please do check the links which are given below. And guys, if you haven't subscribed to our YouTube channel, hit the subscribe button right now, click on the notification bell, and please share it out with your friends. It was an awesome session. It was amazing participation by everybody. I hope you found it very useful to revise this important topic, chemical reactions and equations. And guys, do try this homework question that I have set for you and write your answer in the comments below. It was, and I'm looking forward to reading the answers. I see a lot of you writing the answers here, but I won't tell you what is the correct answer. So here we are interested in the reducing agent. Okay, so guys, do give it a shot and do check out our website. Thanks for joining us in this live session, and we are having these live sessions daily at 8 p.m. for physics, chemistry, and maths. So do check out the notification that goes out, I think around 6 p.m. or yeah, around 6 p.m. And please don't miss any of the live classes, and also share it out with your friends. What is tomorrow's live session, guys? I'll also probably decide on that. Maybe it's another chemistry session tomorrow, and then we'll have a math session day after tomorrow. So guys, you'll get out get the notification. So do check out the sessions which are useful for you, and please hit the notification bell so that you don't miss these, right? And whatever topics you guys want to me to cover, do put it in the comments. I may not be able to address all the topics, you know, but we'll see which is the ones where you're we are getting maximum feedback on. And it's really awesome to read everyone's comments and feedbacks. So thanks for your love and support. I really enjoy reading everybody's comments. Okay, thanks guys. Take care. Hope this was a useful session. Bye bye.